Hi team, it's me Kim, and I'm here to share with you the work that we are doing at the Eastvale STEM Academy. So over the next couple of minutes, I'm going to share with you our instructional focus, which is 21st century skills through project-based learning. Science in the real world encompasses inquiry, problem solving, collaboration, critical thinking, and pretty much the 21st century skills. Think of a doctor and engineer and how they approach problem solving or how they have to go about finding answers to a question. So one of the things that we are focusing on in STEM is the 21st century skills. We're also focused on what the district is focusing on, which is math, literacy, and closing the gap. So we're trying to incorporate literacy, math, and GSS standards into our project-based learning, as well as helping our students understand the scientific research methodology and engineering processes, and then helping them develop grit and perseverance along the way. Many of you have seen this infographic for 21st century skills. Creativity, collaboration, critical thinking, and communication. And here Michael Fullen added in character and citizenship. So when we think about the work that we're doing with our semester-long project-based learning in science research, we do focus on helping our students develop these 6 C's. This infographic contains all the elements of project-based learning. If you have heard of Buck Institute for Education, they are very well known for PBL and the gold standards. So it always starts with a driving question or a challenge, and students then go through sustained inquiry and they apply their 21st century skills. One of the big important component of PBL, or the element, is that students have choice and voice. Another important element of PBL is the feedback and revision. Students are always given ongoing feedback and they have multiple opportunities to revise. And then finally, it ends with presenting their research to an authentic audience. I think project-based learning is just so important for our students because in the real world, we're not given a set of instructions to do something or to solve something. We have to kind of go through the process of inquiry and trying to critically think and to collaborate and to be creative in coming up with solutions. And so PBL is very important. So you can see the statement here from the Buck Institute. I totally agree that it helps our students be successful. One key component of PBL that I think is very important is the role of the teacher, or in this case, a role of multiple teachers as they mentor students through the PBL process. That's one of the things that we actually implemented. We tried to implement it loosely last year, but this year we implemented with some fidelity. And so I'm going to share a little bit about the work that we're actually doing.
This video is an overview of the Science and Engineering Research Project completed in the Eastvale Academy. There are essentially 3 parts to this project. The first is the research, the second is the experiment, and the third is the presentation. During part 1 of the project, students will begin researching their chosen topics. They will need to become experts by diving into previous research in the form of books, articles, published research papers, and even contacting experts. This part of the project also includes taking notes, analyzing the found resources, and learning about terminology related to their project. In part 1, students will plan what they're going to do for their experiment, and they may need to revise their question or hypothesis and even do additional research as they discover what is and is not possible. Research continues throughout the other parts of the project as well. During part 2, students will conduct the experiment. The expense of the project varies based on what their experiment is. Some students have been able to reach out to universities and use machinery or facilities not available here at ERHS. This networking has proven invaluable, and the connections students make with professionals and college students will last well beyond this project. During the experimental phase, students need to document everything that they're doing, taking photos and videos of the process and gathering all the data they possibly can. Part 3 is the presentation phase, where students put together their collected data, articulate the results, and draw conclusions. Students will create a digital poster documenting their project and their findings and will present twice, once to their language arts class and once to a panel of STEM teachers and staff. Many projects will then receive invites to participate in our Eastvale Science Expo in January. From the expo, certain projects will move on to the district science fair competition. From there, we hope to have projects represent us at the county and state level, and possibly even internationally at the International Science and Engineering Fair, or ISEF. The goal for this project is not to collect the grades and the awards at the end. The goal is the 21st century skills for student and society well-being skill set that students are gaining in the process. Critical thinking, problem solving, collaboration, communication, citizenship, creativity, and character.
I believe our huge success with project-based learning is not having it as an extra research for the kids, but we've embedded it throughout our classes. And so we've done a lot of cross-curricular planning with our language arts teacher, our science teachers, our math teachers, and now we're working in our elective teachers. At the start of the year, the students receive a rubric that incorporates ELA standards, math standards, and science standards into the project timeline. So they're well aware of what is expected of them. And then also our teachers actually teach that throughout the ELA math and science classes to help our students understand and to master those standards. We require this project for all of our 9th and 10th grade STEM students. And by doing that, it allows us to see growth from 9th and 10th grade. So how do we manage over 250 research projects? We do it through Canvas, which is a learning management system. And so all of our students, all of our 9th and 10th grade students, as well as all the teachers are on this, and we're able to access and monitor the students that we are mentoring through this process. So after a semester, this is what the students produce. This is their work, and you can see that there is some research. They have data. They've gone through the methodology, they've experimented, and so we've adopted this template actually from the college university where college level students present their scientific research. Also, at the end of the semester, they not only present their research in their ELA class and get scored on literacy standards, but they also present to a panel of other teachers and other professionals that we invite from the community. So then they also get a score there, and they get feedback through the rubric that we use that incorporates ELA, math, and NGSS standards. Remember that one of the element of PBL is presenting to an authentic audience. So not only do they present in their ELA class and a panel of teachers outside of their normal schedule, we hosted our second annual Eastvale STEM Expo this past January, and this is where we invite the community and we showcase all of their research, and we have them stand by their board to share it, but we also have activities for all grade levels. We are now in year 3 of doing this work with project-based learning, and we've seen a lot of growth within our program. And so currently, again, as I said, we are requiring all 9th and 10th graders to do the research. We have all STEM teachers, all hands on deck in regards to mentoring projects. We mentor between 8 to 12 projects each teacher, and we continue to involve the community in regards to the process. One thing that we've added this year is involving the parents and hosting a parent info night specifically on the science and research project. We explain the why to our parents, and we try to change their mindset so they don't think that, oh, this is just an extra science fair project that we have to do again. No, we explain the importance of the research skills, the literacy skills, the math skills that are needed to be successful in STEM fields. So I mentioned a lot about our focus on literacy and math and our 21st century skills, but I guess my question to the team is, how do I go about measuring it now? We really want to look closely at, are we really impacting literacy and math scores and skills in our students? And how do you go about measuring 21st century skills? Any feedback or ideas would be helpful.